To be honest, unit rates is something y'all probably have done. Might have done it a little bit last year, but it wasn't combining equations, okay, and it wasn't also adding tables and graphs. So that's really what we're going to be working on today. All right, so it says to compare proportional relationships represented in different ways. Find the unit rate or the constant of proportionality for each representation. Okay. So one of the first things that I want y'all to understand with this first essential question, let me see if I can make this a little bit bigger. Okay. It says, how can you compare proportional relationships represented in different ways? Okay. What I want y'all to write, okay, and if y'all don't get this all written down, it's fine. I'm gonna put it on a video. Okay. By comparing their constant of proportionality. Okay. That is also known as your unit rate. Okay. You compare the constant of proportionality. It's also known as your unit rate. All right. For this next one, how can you find the unit rate or constant of proportionality for a relationship represented in a graph? Okay. So real quick, I'm gonna go back up. Okay. So obviously this is a graph, right? Okay. And typically it's gonna be on a coordinate plane. Okay. The biggest thing that I want y'all to remember, okay, real quick, if I was to just draw a simple coordinate, okay, simple coordinate plane. Okay. When you go left and right, that is X. Okay. Your X values go left and right. Okay. Your Y values go up and down. Okay. Now, that's also typically on most graphs, but that's a basic concept that I think some of my students been struggling with. I wanted y'all to remember. Okay. So if you're looking at our graph, you see this first point right here where it says 2, it's a comma and then 50. 2 is my X. 50 is my Y. I wrote that ugly, but 2 is my X. 50 is my Y. Okay. Same for 375. 3 is my X. Okay. And then 75 is my Y. Okay. Now let's go back to this question. It says, how can you find the unit rate or constant of proportionality? Okay, I'm gonna be saying those two words a lot because I want y'all to remember that is the same thing. Your constant and your constant of proportionality and your unit rate is the same thing. Okay, one way that you can find those, okay, so you can find the unit rate by dividing, okay, then I'm gonna write this going vertically. You can divide y divided by x. Okay, so when you're dealing with we're dealing with a coordinate plane or with a graph, you can find your unit rate if you divide your y value by your x value. Okay. Okay, the second thing that you can do, okay, when you're dealing with trying to identify your unit rate or your constant of proportionality, you got to find or identify the point 1R. Okay, now I know y'all like, what? What does that mean? Uh-oh. I don't know why I didn't show it, but it's the point 1 for X and R for Y. Can somebody tell me why the point 1R would help us to identify our constant? Anybody? Anybody? So you got to think your unit rate is what you are trying to find in this per. Okay, so if we deal in miles per hour, okay, that's for 1. Okay, you're trying to figure out the unit rate breaks it down to how much do you pay for 1? How much do you do for 1? So where your X is 1, okay, that is literally going to be a unit rate. So either of these two ways, you can identify your unit rate. Let's go back to this graph at the top. So for instance, if I'm looking, here's X, where X is 1, right? I go over to the right one. If I go up, my Y point would be here. Now, the only hard part about that is you would have to estimate. Now, to be honest, if I'm estimating, I think they might be about 25 because these are going in increments of 10 up for my Y value. So 0, this one right here is 10, then you got 20, then you got 30. So that point is kind of in between 20 and 30, which may be 25. However, we have two other points. Okay. So since I wasn't able to clearly identify that using my first x value, where x equals 1, I can do what? Divide my y values by my x values. So if I'm looking here for this point, my y is 50, my x is 2. All I got to do is 50 divided by 2. 25. Here's my next point. 75 divided by 3. 25. So this graph has a constant of proportionality of what? 25. Okay, so there's two different ways you can find your constant of proportionality in your graph. Okay, identify wherever your x value is 1, or you divide your other points, divide your y value by your x value. Can I get thumbs up if y'all understand what I'm saying with that? All right, so that last one. It says, why can you use the constant of proportionality with any representation? The constant of proportionality represents the fundamental rate of change inherent to the relationship. Okay. So what this is trying to say is when you're dealing with tables, equations, and graphs, okay. So when you're saying like the constant of proportionality and you're dealing with an equation or you're dealing with a graph, what we're saying is these are equivalent, they're equal. Okay. That's why like when we've been dealing with the ratios, all of this stuff it correlates with each other. Okay. And it's just can you kind of identify a pattern? Can you identify a rate of change that is similar within these equations or numbers or tables? Okay. Okay, let's try this one. So, do you know how? So, this is gonna kind of work with this on our own. So, it says Amanda babysits and Petra, or yeah, I think it's Petra, does yard work on weekends. The graph relating Amanda's earnings to the number of hours she babysits passes through the point 0, 0 and 424. Real quick, the point 0, 0 is known as our what? So your 0, 0 is origin. If the line does not go through the origin, it's not proportionate. It has to go through your origin. Okay. Now our second point is 424. Okay. So it says the table below represents or relates Petra's earnings to the number of hours she does yard work. Are y'all listening? I promise y'all are going to have questions like this on the test. But this is known as comparing, okay, two different proportional relationships. They'll give you a graph and then they'll give you a table, or they'll give you an equation and they'll give you a table. And all you got to do is kind of use some of the stuff we just learned. Okay, so for instance, let's work on Amanda first. So, can somebody tell me what's Amanda's constant of proportionality based off what we see? What is Amanda's constant of proportionality? So this is Amanda. So basically, it just gives us her points. So guys, when you're trying to find your unit rate, it's two different ways. It's not graphed, right? So we can't graph it, even though they gave us 2 points. Okay. So you can either find the point on the graph for what 1 equals, or you can divide y divided by x. When you are dealing with the coordinate plane, okay, or you're dealing with a coordinate pair, excuse me, okay, the first number is x, the second number is y. Guys, you can't do nothing with 0, 0. Okay, so for Amanda, if I'm giving 4 and 24, all you gotta do is 24 divided by 4, yo. What's 24 divided by 4? So I'm assuming she earns about $6 per hour. Okay, so we found Amanda's. Here's Petra's. Okay. All right. Looking at the table, can somebody tells me, excuse me, can somebody tell me you good, what is Petra's earnings per hour? It's 5. How did Abby get 5? He divided. Okay, so listen, this is another really important thing when you just dealing with the input and output tables. Okay. They'll give you input and output tables two different ways. This is an example of an input output table that's horizontal, meaning it's going left to right. Okay, when you are given a horizontal input output table, write this down. The first number is going to be X, the second numbers are going to be Y. Excuse me. So the numbers on the top are going to be X, the numbers on the bottom are going to be Y. Okay. Now, they could literally write this same thing vertical. Okay. And if they wrote it vertical, okay, it would be 3, 6, 9, and then 15, 30, and 45. That's a very ugly 9, but I'm going to fix it. Okay. So when it's horizontal, number on the top or your numbers on the top are X, the numbers on the bottom are Y. When it's vertical, the numbers on the left are X, the numbers on the right are Y. Okay. Remember to find your unit rate, constant proportionality, divide 45 divided by 9, which is 5. So Petra earns about $5 per hour. Okay. Now, going to back to what are we doing here? We're trying to compare them. So it says who earns more? Amanda. So Amanda earns more per hour. Okay, let's try this one for number 5. Milo pays $3 per pound for food at Pat's Pet Palace. The graph below represents the cost per pound of food at Mark's Mud Market. At which store will Milo pay a lower price per pound for food? The first unit rate, okay, they don't give us a graph. They don't give us an equation. They just describe it. So they tell us Milo pays $3 per pound for dog food. That's her unit rate. Okay. Now, for our second one, I'm going to highlight this one green. Okay. Dog food at Mark's Mud Market. Okay. So if you're looking at this, right, you'll realize you got to do a little bit of estimating. So we do have a point where 1 is, which would be right here. Okay. Then we have a point here. Okay. We got a point here. Then we got a point here. So the only bad part about this, if I'm being honest, none of them are directly on a line. Okay, none of them are directly on the line. So if I'm looking at this first one, I go over 1, it's not at 5. I would say that one is 4. So another thing you can always do, guys, you can make your table. Okay, make your table for your X and Y values. Okay, so if I go over 1 for X, that's 1. Then I go up 4, that's 1, 4. Okay, for 2, I went over 2 for X. Remember, you go left to right first. And then I'm going up. Okay, I would say that's about 8, estimate 8. And then I go over 3. I would say like 11 or 12. Considering these numbers, I'm going to say 12. Okay. Once again, you find your unit rate or your constant of proportionality, divide Y divided by X. Okay. Or I can look at where X equals 1. So for the Mark's Mud Market, it would be $4 per pound. So this one would be $4 per pound. Okay, so real quick, and I think most of y'all got this part. Pat's Pets Palace. All right, pretty good, pretty good. All right, let's try this one. Okay. The graph shows the amount of savings over time in Eliana's account. Lena, meanwhile, puts $50 each week into her savings account. If they both begin with 0, who is saving at a greater rate? Okay, so here you got Lena, okay, and then you got Eliana. All right, I'm gonna give y'all once again, give you about 5 minutes. Let's see if you can get that one on your own. We'll reconvene in a few minutes. All right, good people. So with this one, okay, first thing, okay, for Lena, it tells us a description of how much she pays. So we don't even have to necessarily do any math for this one because they give us exactly what is her unit rate, excuse me, which is $50 per week. Okay, that's $50 per week. Okay, now for Eliana's, okay, remember it's a couple of different things that you can do to identify your unit rate in the graph. Okay, what is my y when my x is 1? So if I go over 1, okay, and I go up 1, it's here. Okay, if I go over 2, go up, it's here. Now the cool thing about this one is go over, go up, it's perfect numbers. Okay, so you can pick a wide range because unless you understand the pattern for y, okay, when you go over 1, it's not necessarily going to tell you what that number is, right? Okay, so if I go over for 2, and let's go ahead and make an input output table for this one as well. So of course, you got your 0, 0. We got 1. We'll come back to that one. For 2, we got 94. Okay, and then we don't necessarily know what we got for 3. And then last one I'm gonna do for 4, we got 188. Okay, so remember, y divided by x is going to give us our unit rate. Y divided by x. Okay, I was kind of running out of space, so I kind of had to do it here. So if I did 94 divided by 2, what would that give me? Good. Okay, so Eliana's is actually $47 per week. Okay, so the question asks us who is saving at a greater rate? Lena. Okay, this is another thing. People be like, you never gonna use this math. Yes, you are. Okay, you do want to kind of understand how to do this because even with this is just understanding how to save and how to use, input output tables, how to use a graph to calculate your savings. You're going to need that. Okay. All right. And then if another part of this, guys, if I was going back to fill in these numbers for my input table for here, I would have 47, right? What would that give me for Y? Or if my X is 3, what would that give my Y? There you go. So if y'all wondering how did she get that? We already said that our unit rate was what? Okay, so this is adding a little bit of a layer to it. We'll talk about this some more tomorrow too. Another way you can do these, and you will see these also as or in equations. Okay. If you get an equation and it's proportionate, it should be y equals K, and the K is for constant. No, constant does not start with a K, but in this formula it does. It's K times X. Your constant times X. Your total equals your constant or unit rate times X. So if I was to plug this in, so say I said how we just found 141, right? I would have said 141 equals, and that's 47 times 3. Okay, that's another way your unit rates will be communicated. Okay, you'll have questions. Okay, they'll have descriptions, they'll have graph, they'll have input tables. All of these will pretty much be coordinated together for you to find unit rates. Okay, all right. Can I get nonverbal 0 to 5? Remember, 0, I have no idea what I'm doing, Mr. Sales. 3, I'm somewhere in the middle, Mr. Sales. 5, this is the easiest thing I've ever did in my life, Mr. Sales. Just keep your fingers real calm, make it real simple. That's pretty good. Pretty good. All right, that's pretty good. All right, keep it going.